everyone, this video is about partial fractions, topical past paper questions. Question 1. Express in partial fractions. The first thing we want to do is to check whether it's improper or proper. The order is 2 because of 4x squared. The order is 2 because of 2x times x squared. So it's improper. We have to do polynomial long division. And this is the dividend, the numerator. The divisor, we have to expand 2x times x and so on, expand everything and use this expanded form of the divisor, and then we divide 4x squared divided by this. It's gonna be 2, so we multiply 2 times this, 2 times this, 2 times that, and we get the remainder x plus 7. And so the mixed algebraic fractions would be 2, the quotient, plus the remainder divided by the divisor. So we use the partial fractions decomposition only for this part. We have x plus 7 over 2x minus 1, x minus 3. We use the linear form for the 2x minus 1, also linear form for the x minus 3. Multiply both sides by the denominator, cancel out, we get this, and we multiply, cancel out, we get this, multiply, cancel out, we get this, and then we plug in the zeros of x minus 3, which is 3. So if we plug in x equals 3, 3 plus 7 is 10. Plug in 3, we get 0, of course. Plug in 3, we get 2 times 3, 6 minus 1, 5b. So b must be 2. And the 0 of this factor is 1 over 2. So we plug in x equals 1 over 2. 1 over 2 is 0.5. 0.5 plus 7, 7.5. 1 over 2 minus 3. So 0.5 minus 3 minus 2.5a. And we plug in 0.5, we get 0, of course, from here. So we have only a equals minus 3, and the final answer is therefore 2 from the quotient, minus 3 the a coefficient, and 2 the b coefficient. Next question. Express in partial fractions, check the order. X squared, order is 2. And here we have 2 plus 3x all squared. So this means we have 9x squared and so on. 9x squared times x, we have 9x cubed. So we have the order 3 for the denominator. So it's proper. Proper means you just have to do the partial fractions decomposition. For the first term, this is linear. For the second term, this is repeated linear. Repeated linear means we have to use this form, cancel out, and we get this. Multiply, cancel out, we get this. Multiply, cancel out the power, so we have this. And multiply, cancel out, we have this. And we plug in the zeros of this and this. So the x is 1 because of this 1 minus x. If we plug in x equals 1, 5 times 1, 12 times 1, and if we plug in 1, we have 3 plus 2, 5, squared 25. And if you plug in 1, we get 0, plug in 1, we get 0, so a must be, and this is 25, so a must be 1. And we use minus 2/3 because if we plug in minus 2 over 3, we will get 0 for this factor here. So we plug in minus 2 over 3, 5 times minus 2 over 3 minus 7 over 3, 12 times minus 2 over 3 all squared is 4 over 9. 4 over 9 times 12, 48 over 9. And yeah, we plug in, we get 0, plug in, we get 0. And we plug in 1 minus 2 over 3, so that's 1 plus 2 over 3, 3 over 3 plus 2 over 3, 5 over 3 c, and then we multiply throughout by 3. 8 times 3 minus 10 over 3 times 3 cancel out, and if we multiply by 3, this is 48 over 3 or 16. 24 minus 10 is 14 plus 16, 30. So 30 divided by 5 is 6. And for the b coefficient, we can use any random number, so we're just going to use 0, the simplest one. Plug in 0, we get just 8 on the left, and plug in 0, we get 2 squared 4, so 4a, but the a is 1, so just 4. Plug in 0, we get 1 times 2, which is 2, so we have 2b. Plug in 0, we get 1c, the c is 6, and therefore the b must be minus 1. We have the a, the b, the c. We have the final answer then. A is 1, b is minus 1, the c is 6. Next, it's a bit different because we have a here. A is a positive constant, so it's just a constant. The order is 1 for the numerator, the order is 2 for the denominator because of 2x times x, and it's proper, just do the partial fractions. And this is linear, so we use this form. Also linear, we use this form. Multiply by the denominator, cancel out, we have 5a. Multiply, cancel out, we have a times 3 minus x. Multiply, cancel out, we have b times 2x minus a. And we have to use x equals 3a if we want this 3a minus x to be 0, so we plug in 3a. There's nothing to plug in here because there is no x, so we just rewrite the constant, which is 5a on the left. On the right, 3a minus 3a is 0, and 2 times 3a, that's 6a. 6a minus a, 5a, so we have 5a times b, and the b is therefore 1. And we use a over 2 because we want this factor to be 0 now. So if you plug in a over 2, this is just 5a, nothing to plug in. Here we plug in a over 2, so that's 0.5a. We have 2.5a. Here we plug in a over 2, they cancel out, 0. So a must be 2. And therefore the final answer is the a is 2, the b is 1. That's it. I'll see you again next time.